All right, so we're going to start out with journal 27 here, and we're going to talk a little bit about multiplying x's. Now, we've done this before in when we were factoring, and we had to multiply x with x. So in this case, if we have two x's and we multiply, we get x squared. And the reason why that's because, well, we have to think about what is the exponent on these x's for a minute. So this x has a power of 1 by default, and so does the other one. So it turns out when you multiply x's, you are actually adding the exponent. So in this case, 1 plus 1 gives me 2. So if I had this scenario and the base are the same, meaning that these are both x's, then when I multiply these x's, I'm going to add the exponent. So 2 plus 3 gives me x to the 5th power. And so when we multiply two things are the same base, we add the exponent. So what I mean by base here is the bigger thing is your base, and then you have an exponent that is like the super subscript. So we call this guy the base, and the super subscript the exponent, or the tiny number that sits above the exponent. And so this becomes really important vocabulary that you're going to hear me talk about as we proceed in this new unit. So essentially, exponents are basically telling you how many times are you multiplying itself. So in this case, you're multiplying x 5 times. So exponents, I'll just write down here, tell you how many times you multiply itself is my short definition. All right, now that we've talked a little bit about exponents, let's look at the exponent properties or rules that we apply to exponents. And there are 5 rules I'm going to be teaching you today. You've already noticed one of them. It's the product rule. When you multiply exponents, when you multiply two things that have the same base, you add the exponents. That's what we call the product rule. So here I have the x's. Right? When we multiply the two things that have the same base, we add the exponent. So in this case, I'm adding a with b. And so to give you a short example let's do a different example. So let's say 7 times x to the negative 3rd power. Well, in this case, you're adding 7 plus negative 3, which is x to the 4th power. And so there we go. We've used the product rule to simplify this math expression. So we're just adding the exponents when we multiply. So in this case, if you're dividing, or the quotient rule says that when you divide two things that have the same bases, you actually subtract the exponents. Specifically, the top exponent from the bottom exponent. You want to subtract the top from the bottom. So a minus b. And so if I gave you a scenario that's like x7 and over x to the 3rd power. If you subtract 7 from 3, you get x to the 4th power. And so there we have it. We've simplified that expression. Then the next one here is x to a power, but then there's a power outside using a parentheses. So if you notice there's a parentheses and there's a exponent outside, that's when you want to multiply the two exponents together. And so that would be xa times b. So to give you a short example, if I had like maybe x to the 4th inside and then like a negative 3 outside, in this case, because there's an exponent outside, I have to multiply these two. And so x is to the, 4 times negative 3 is negative 12. So to the negative 12 power. All right, and our next one here is x to the 0 power. So it turns out x to the 0 power is actually just 1. And I'll prove that and why that's the case. So first off, if you have something that's let's start off with a simpler example. So if I have a number like 4 and I divide it by a number that's the same, so 4 divided by 4 is 1. Anything divided by itself is always going to be 1, right? So in that case, if I say that x divided by x, well, that's also going to equal 1. So I know that from just intuition. But what if I were to do this problem, simplify this problem using the quotient rule? So what I mean is, let me redo this problem over again. So both of these x's are to the 1st power. And if I use the quotient rule, that means when I divide these x's, I have to subtract the exponents. So 1 minus 1, the top minus the bottom, is going to give me x to the 0 power. Well, didn't we just say a moment ago that x divided by x is 1, right? Turns out when you use the quotient, x is now to the 0 power. So that means that these numbers, because you started off with the same expression, both of these are the same, but they just have different types of way you write it. Well, they have to be equivalent to each other. So that's why we can say x to the 0 power is equal to 1, is because we're applying the quotient rule with the idea of anything over itself is 1. And so just remember, x to the 0 power is always 1. So I can have x is any number. So if I had like x is equal to 1,000, 1,000 to the 0 power is 1. Or a -3 to the 0 power is 1. Anything to the 0 power is 1. All right, and our last one here is a negative exponent, which is kind of weird, the negative exponent one. So just hang on with me for a sec. Basically, whenever you have a negative exponent, we don't like negative exponents, so we make it into a positive. And to do that, we have to throw the base and the exponent into the denominator. And so when you see a negative exponent, we're going to throw it in the denominator, or basically we would throw it in the opposite side, so either the numerator or the denominator. So let me just back up a moment and explain why this is the case. So I'm going to show you a few examples, and hopefully this will make more sense. So anytime you have a negative exponent like this, all right, so let's say I have something like that's 3, and I raise it to the -1 power. So let me actually put this in parentheses. And so if I take -3 to the -1 power, well, it turns out negative exponents are basically saying take the reciprocal. And we've learned that reciprocal just means to flip the fraction. So if I wrote 3 as a fraction, well, technically it's 3 over 1, right? And so if I take the reciprocal, because of this negative exponent, this would be 1 over 3. And so now I don't have to deal with a negative exponent because I've taken the reciprocal. That's actually what you're doing here for this x. When you are raising it to like, let me write an example here. When you're raising it to the -1 power, what you're doing is you're throwing this x, which is technically over 1, and you're taking the reciprocal, so then it's going to be 1 over x. And now that power, the 1, is now a positive 1. So let me give another scenario. So if you have something that's like maybe 1/3, and it's raised to the -1 power, well, when you take the reciprocal, it's going to be 3 over 1, right? So if the item, the number here is already in the denominator, it gets thrown into the numerator. So it switches sides. And so if I have, like, let's say an x, let me do a different example here. So let's say I have x, and it's to the -3rd power in the bottom. Well, to make this exponent back to a positive, I have to throw this x to the top. So now it's x to the 3rd power over 1, but that's still technically x to the 3rd power. So how I really think about these is anytime I have a negative exponent, I need to make it into a positive. How I do that is by switching where it's located. So if it doesn't have, like, it's not a fraction yet, I just throw it in the denominator, like this one. If it is in the denominator, I throw it back in the numerator. So let me do a couple more examples with you guys before we move on to the next thing. So let me just grab this, put this to the side for a moment. So let's say I have like, so another example is like x to the -2 power. Well, because I notice that that's a -2, I'm going to throw it in the denominator as x to the 2nd power. And now it gets to be a +2. And the top here has to be a 1. So if you throw something in the denominator and you don't have anything in the top, you're going to make it a 1. If I have something like -7, but it happens to be in the denominator, I need to make this exponent a positive again, so I'm going to move it into the numerator. And so that'd be x to the 7th power. Now it's a positive over 1, but but you don't really need to write that 1 because it's in the denominator. Anything over 1 is itself. And so now the exponent is positive. So in the future, anytime you have a negative exponent, we got to make it into a positive exponent. And to do that, you have to like basically switch or flip the sides. All right, let's look at one more slide here. Okay, so in this slide here, I'm going to be showing what it means to simplify an exponent expression. So there are two main rules for simplifying exponent expressions. One, all exponents need to be a positive exponent in the final answer, just like I was talking about in the last rule, is that if you have a negative exponent, you got to switch the sides to make it a positive exponent. And also, you got to make sure that the bases are all the same. If the bases are the same, then you combine those exponents together. So like in this case, when I'm looking at this one, you have a 4, an x, and a y. None of the bases are the same, so I can't combine. But I notice right away I have a negative exponent. This x here is to the negative 2 power. So what I have to do is force this one to be a positive exponent by making it into a fraction. So anytime I spot a negative exponent, that kind of cues me to make a fraction and throw anything that is a negative exponent in the denominator. So I'm going to put the x squared in the denominator, and now it gets to be a positive 2 in the denominator. Now the 4 and the y to the 5th power both have positive exponents, right? Because this 4 technically has a power of 1. So they're both positive, so I'm going to keep them in the numerator. So if they don't have a negative exponent, you don't want to throw this in the denominator. Only the negative exponents. And then that's it, because I can't combine a 4, a y, and an x together. So that would be it for that simplifying. So I'm done simplifying. All right, so in the next 2 slides, I'm going to be working out problems directly from the homework. So if you need help with the homework, I would keep watching. So in this slide here, I'm going to be doing homework problems from packet 6 on page 1. And so I'm going to start off with problem 1 here. So this is the problem, and I notice immediately inside, so typically like order of operation, you want to work inside the parentheses to see if you can simplify anything. But inside I have a 4, an a, and a b as a base, and so I can't combine anything here. So afterward, on order of operation, you typically want to do exponents next. And to take care of this exponents, I need to distribute the exponent. So I'm going to go ahead and distribute that exponent in. And so that gives me 4 to the 5th power, because technically this 4 is to the 1st power. So if you do 1 times 5, you get 5 for that exponent. Remember, when an exponent sits outside, you have to multiply the exponents together. And then this a has a 2, so 2 times 5 gives me 10. B is to the 3rd power, and so that there's a 5, so 3 times 5 gives me 15. And so looking at this here, I have 4 to the 5th power. So I'm going to work that out in my calculator. So what is 4 to the 5th power, or 4 times itself, 5 times? Well, it's 1024. And then we have a to the 10th power and b to the 15th power. And I think that's it, because I can't really combine anymore, and I don't have negative exponents. So I'm good to go. All right, and the next one here, I have a fraction, and it looks like the x's here are being divided. And so remember, when we're dividing exponents, we want to subtract the exponents. So this is going to be asking myself, okay, what's x 8 minus 6? Well, that's just 2. And so it looks like here x is to the 2nd power. Okay, and that is not a negative exponent, and I can't combine. That's all I have is x. So this is done. Problem number 3, I have like a fraction. Oh, and I think there's a 2 outside here. I forgot. Sorry. Squared on the outside. And so what I'm going to do first is simplify the inside the best I can. A and b won't simplify, but 4 and 2 will. 4 and 2 can be both reduced by 2. So 2 goes into 4 twice, and 2 goes into 2 one time. So technically this is really 2a to the 3rd power. Now if this is a 1, 1 times b to the 4 is still b to the 4. And then there's still a 2 out here. And so exponents, when you have an exponent outside, this actually distributes to everything inside. So what I mean is it's going to distribute everything in the top and everything in the bottom. And so this 2 will go to this 2, to the a, and to the b. And so that would make it 2 to the second power, a to the 6th power, because we multiply exponents when it's in a parentheses. And then b, 4 times 2 gives me 8. And so now I have this. And so by looking at it, it looks like I can simplify maybe like the 2 and the 2. So 2 squared gives me 4. I have a to the 6th power on top and b to the 8th power. And looks like from here I can't really simplify because a and b don't simplify. They can't combine. So this is it because I don't have negative exponents either. All right, in the next one here, number 5, what I notice is I have an x and y inside, so I can't simplify the inside, but I have a negative 3 outside, so I have to distribute that negative 3. So I'm going to go ahead and distribute that inside. So that makes it as x to the 4 times negative 3 is negative 12. Y is now to the 7 times negative 3 power, which is negative 21. And so looking at this, I immediately notice I have a negative exponent, so that cues me to make a fraction. And so to make this into a positive, I have to throw these in the denominator. So x is now a positive 12 and a negative, y is to the 21st power in the denominator. Now in the top, because I don't have anything, by default I have to write a 1 in the top. And so that's it. Because now I can't combine x's and y just like I couldn't in the beginning, and now they're positive exponents, so this is it. All right, let's do number 6 together, and that'll be it. Okay, so here I have a fraction going on, and I have x's and y's. So what we are going to do is we have to divide the x's and y's, right? So I like to do this like one at a time. So I'll focus in on the x's first. So if I were to divide the x's, I have to subtract the exponent. So this is really saying 11 minus negative 3. And then if I were to do the y's, right, I would have to subtract the exponents on the y's. So this is going to be y 10 minus negative 1. Well, when I subtract, it looks like there are 2 negatives, and because there was a negative in the denominator. So I have to add. So this becomes a plus sign, and this becomes a plus sign. So it looks like x is to the 11 plus 13, which is 14. 11 plus 3 gives me 14, and y 10 plus 1 gives me 11. And so x is to the 14th power and y is to the 11th power. Both of them can't combine, and both of them are positive exponents. So this is it. All right, I hope that helps out with the homework problems. Until next time, guys. Bye.